With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So here we have a question. We have given two statements. We have to check which statement is correct and which statement is wrong. So first of all, I'm going to read the second statement. It is saying that statement 2 is, if fx is a periodic function with a period t, then first thing is 0 to nt fx dx, it is equals to n times 0 to t fx dx, where my n belongs to natural number. And the second thing is given in the statement 2 is integration for nt to nT+a fx dx, it is given by 0 to a fx dx, where my n is again belongs to natural numbers. Okay, so here I'm going to check my statement 1 is correct, statement 2 is correct or not. So I'm writing here my statement 2. Okay, statement 2. So basically we know one simple identity for the definite integral, which is given by, if we have integration a to a plus n times the time period, or you can say the period where the function is periodic, okay, fx dx, then it is given by n times of integration 0 to t fx dx. Okay, this is the simple identity that we already know. Now using this identity, let's check whether the statement 2 is correct or not. So first statement is given by integration 0 to nt fx. Okay, so it is absolutely correct, because here you can write this thing as integration 0 to 0 plus nt fx dx, it is equals to n times, as per the question side, 0 to t fx dx. Okay, so this is absolutely correct, because you can see here in place of a we have 0 here. Okay, so in place of a we have 0 here, and here there is no real role of 0, and answer is the n into n, and the limit is 0 to t. Okay, so this is correct. My first point is correct. Now move to the second point. Second point is given by nt2 integration nt to nt plus a fx dx is equals to, it will be given by, here we have in place of a we have nt, in place of a we have nt, so there should be no nt, and here the multiplication of a, it is 1. Okay, 0 to a fx dx. Okay, so this should be the integration. Let's see. Yeah, this is given in here. Okay, so this is also correct. So our statement 2 is absolutely correct. Now moving to the statement 1. Using the statement 2, I'm going to solve the statement 1. So basically I'm going to write here statement 1, and statement 1 is simply integration 0 to npi+v, integration 0 to npi+v mod of sin x dx. Okay, and it is given by, here this is the something which we have to prove actually. Okay, so if this will become, then we can say that this integral is equals to this thing. Okay, now I'm going to integrate this thing. So here I'm writing it as, I'm splitting the limits, it is 0 to n pi sin x with the mod dx plus integration n pi to npi+v sin of x mod dx. Okay, now by the above identity, this identity, I can write this thing and this thing as n times integration 0 to t sin x, 0 to pi, sin x with the mod dx plus, here we have 1 into integration 0 to v sin x mod dx. Okay, now in the question we have given that my v is greater than equals to 0 and it is less than pi. Okay, and we all know that from 0 to pi my sign is positive. Okay, from 0 to pi my sign is positive. If my x belongs to 0 to pi, my sin x will be always positive. That is, we already know. Okay, now moving further, here I'm going to integrate this thing. So it will be n times 0 to pi. If my function is positive, then we can say that it is written as sin x simply, plus integration 0 to v sin x dx. Okay, I'm going to integrate this thing. So basically integration of sin x is nothing but minus cos x limit 0 to pi plus minus cos x limit 0 to v, and here I'm going to apply the limits. So it will be n into, on putting pi it will be minus 1, and minus minus become plus, it will be plus 1, minus on putting 0 it will be 1. Okay, and basically it will be minus 1 because we already have minus here. Okay, plus on putting this thing it will be minus of cos v minus of cos 0. Okay, so this is the limit. Now I'm going to solve this thing. It will be 2n, okay, plus here it is 1, okay, plus 1 minus cos v. So this is the simple integration if I say I. Okay, so this is my integration. Now let's check what the question gave us. It is 2n plus 1 minus cos v. This is what we have evaluated here. Okay, so we can say that my statement 1 is also correct. So my statement 2 is correct, statement 1 is correct, and statement 2 is the correct explanation for statement 1. That's why our first option is absolutely correct. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.